In this session, we're going to focus on distributed key-value pairs, which are a popular way of representing and organizing large quantities of data in practice. And in Spark, we call these distributed key-value pairs pair RDDs. If we think back to the functional programming and Scala courses, when we were focusing only on sequential Scala and the basics of functional programming, we didn't work with any data types called key-value pairs, though we did work with a collection type called a map. And if you recall, maps are essentially collections of keys and values. So while we didn't call a map a key-value pair, conceptually it's the same thing. And this concept goes by other names in other languages, such as associative arrays or dictionaries in languages like JavaScript or Python. Though if you think back to the single machine scenario, even though most languages have something like a map or a dictionary as a core data structure, maps, dictionaries, etc. maybe weren't the most often reached for data structure on the shelf of data structures that you had to choose from when you were doing these programming exercises in the earlier functional programming courses. You might have used other data structures like lists or even arrays more often than you might have reached for something like a map. However, in the world of large-scale data processing and distributed computing, the opposite is actually true. It's actually more common to operate on data in the form of key-value pairs than anything else. In fact, when Google designed MapReduce, focusing on all data as key-value pairs was a key design decision based on real use cases involving large amounts of data at Google. In fact, the original designers of MapReduce even explained the rationale surrounding their focus on key-value pairs very clearly in their original research paper which presented MapReduce to the world back in 2004. They said here, "We realized that most of our computations involved applying a map operation to each logical record in our input in order to compute a set of intermediate key-value pairs, and then applying a reduce operation to all of the values that shared the same key in order to combine the derived data appropriately." Or said another way, computations that they were already doing at Google always ended up producing key-value pairs, so they focused the design of MapReduce around this common pattern for manipulating large amounts of data. This is due in large part to the fact that large datasets are often made up of unfathomably large numbers of complex nested data records. So complex elements of a large dataset like the Wikipedia case class we saw in the previous session. And of course the case class that I showed you was just an example and a simplification of such a record. Given such complex records and the need to do computations on them, often data analysts need to project down these complex data types into key-value pairs in order to operate on them. Here's another example of a record. A single element in this case, and it's in JSON, but this is the shape of perhaps a single element that you might find in an RDD. The intuition I want you to get here is that often there are many fields and there are lots of rich nested structure to these records. There can be objects nested in objects, and it could go quite deep. So let's say we have something like this JSON record on the left as our input data, and the analysis that I want to do may focus only on the cities that certain properties are in. So here we have some properties, and I care about the cities and perhaps the street addresses, but maybe I want to do some analysis, and I don't care about the rest of this data, I only care about this part of the data set here. So in this case, it may be desirable to create an RDD of properties of type pair string property, where the key of type string represents the city that a property is in, and the property type here represents the corresponding value like we see in the record to the left. We have a case class for it here, where the property contains a street of type string, a city of type string, and a state of type string. So you could imagine that given a bunch of these properties, it could be desirable to group them by their cities as the key, to do computations then on these groupings of properties by city. This is one scenario where on a large dataset, manipulating your data into a key-value pair might be desirable. As alluded to earlier in the session, in Spark, we call these distributed key-value pairs pair RDDs. And they're particularly useful because they allow you to do special operations per key in parallel, and they allow you to group data by keys across the network. Very importantly, pair RDDs come with special methods for working with data that's associated with a corresponding key. That is, pair RDDs have extra methods related to keys that regular RDDs don't have. So if you try to call some of these methods on an RDD which is parameterized by type integer, so an RDD full of integers, the compiler would say, nope, I can't do it, and it will give you errors saying the method cannot be found. So remember, if you have an RDD with a type parameter that is a tuple or a pair, it is treated specially by Spark. It has special extra methods. And just to give you a sense of a handful of these special methods that we have on pair RDDs, some of the more commonly used ones are group by key, reduce by key, and join. We'll cover these methods in a lot more detail very shortly. But first, you might ask, well great, how do I actually create a pair RDD? It's actually quite simple. Pair RDDs are most often created from already existing regular RDDs using operations such as the map operation on RDDs. So that said, let's do a quick quiz. Let's say I wanted to create a pair RDD from an RDD full of these Wikipedia pages that we saw on a previous slide, such that the key of the pair RDD represents the title of the Wikipedia article and the value of the pair RDD represents the text of the Wikipedia article. What method would I have to call with which arguments to create this pair RDD from this val RDD above? So again, as a hint, you can use some kind of transformation operation to then create a pair RDD. What would you use? It's simple. In this case, I can just call map on the original RDD here, and I pass a function here, which selects the title and the text from the Wikipedia article, and then makes them into an element of a pair. So this is now a pair RDD, and it has all of these special key-value pair transformation methods available to you to be used now. So now the type is what we saw on the previous slide. The type looks something like this now, so it gets all the special methods. So now you can do things like reduce by key or join on this new pair RDD that you couldn't do before on this Wikipedia RDD. In the next session, we're going to dive into a lot more detail about these operations on pair RDDs, so these and more.